Okay. So after doing basics of Python, we are looking into different packages that will help us for data science, which are, in this case, we will look into three major packages: NumPy, Pandas, and Matplotlib. And they are primary packages that will help us to explore data sets, and we will use them often either to either uh, manipulate or handle with data sets, do some mathematical operations on them, do some visualization. There is one more package of interest that we look into, but that we'll do into the later part of the course when we go into machine learning. It is scikit-learn. Uh, these are the primary packages that we look into. There are other packages that we use on and off depending upon need, but as a data scientist, we need to be really familiar with these three packages. So we start our journey with NumPy, and let's see how it goes. Okay. So we ask the question, what is NumPy? So NumPy stands for numerical Python. Uh, if any of you have worked with a software called as MATLAB, this is NumPy is, or many of the codes of NumPy are very similar to what we would do write scripts in MATLAB. So they're very similar. So you would find yourself at home if you're comfortable with MATLAB. Okay. So like MATLAB is a software where most of the variables or all of the variables we look into, they are uh, uh, they are interpreted or they are represented as matrices. Similarly, in NumPy also, we'll have a lot of our variables, in fact, most of our variables interpreted as matrices. Now, NumPy is one of the foundational package for most common data science packages. So other packages that we use, maybe like scikit-learn or pandas, have some implementations of NumPy in the background. Okay, so most of the data science packages that we look into in the back end, they use NumPy as their foundational package, and there are multiple reasons for that. The primary reason is NumPy is high performance multi-dimensional arrays for vectors or matrices. Okay. It gives us high performance multi-dimensional arrays for vectors or matrices, okay, which is very similar to what MATLAB works on. So we are in the same purview. Uh, the idea is this: if we can take concepts and we can represent them as matrices, then we can invoke our mathematical functions from something called as linear algebra. Okay, and linear algebra uh, basically deals with matrices, their operations, multiplication, division, and so on. And uh, one thing, apart with convenience and other things that linear algebra handles, the primary or one of the key highlights of using linear algebra is many of your representations become convenient. At the same time, many of your representation becomes much faster. Okay? So if I had to implement something using basic loops, and if I could take that idea and try and represent that idea in a matrix operation, then that matrix operation inherently is very fast compared to just running simple loops. Okay, so because of this key idea of linear algebra, if we can take packages and if we can represent them as multidimensional arrays, then we can get very high performance operation. Okay. So the key features of NumPy is NumPy has something called as ND arrays, and ND array stands for n-dimensional arrays. And these arrays are fast, they are convenient, and they are space efficient. And we'll look into some examples of why we are talking about it at this week. Okay, they are fast. That is, NumPy arrays are very similar to basic Python lists. But when you take a list operation and you take a NumPy operation, you would see that NumPy operation is much faster than a similar operation done in basic lists. And the reason for that is in the back end, NumPy uses some really neat tricks with linear algebra to make itself much faster. It is convenient because we will see when we have multi-dimensional lists, then the way lists work in Python, you may have different objects, you may have lists of different sizes. Lists are not interpreted as rows and columns. Whereas if I take a NumPy or ND array, I can represent them as rows and columns. I can have uh, one data type of n-dimensional arrays, and those things make it really convenient to again take linear algebra concepts and implement them. And we'll see that we'll be using this a lot. They are also space efficient. That is, when you store ND arrays, you will see that ND arrays take much lesser space compared to similar lists in Python. Again, that goes to say that the implementation behind is again high performance, because of which we are able to save a lot of memory when we are storing ND arrays. Another key feature of NumPy is something called broadcasting. And broadcasting is the ability of NumPy to take matrices and to add rows or columns or scalars of different sizes to matrices, so that they are interpreted in a key way that will be very useful. And uh, once we look at examples, it will be clearer what broadcasting means. And similarly, vectorization is the process of, using matrices to represent ideas rather than writing loops to get things done. And because of these key features of NumPy, NumPy is very famous, and it stands as the foundational blocks that we'll be using for our journey into data science. Okay? So it's a very key package. Now, when you look at NumPy, maybe I can, yeah. So when you look at NumPy, we talk about two different kinds of arrays. We can talk of rank 1 and rank 2 arrays. Rank 1 arrays are basically one-dimensional. One-dimensional in the sense of storing uh, different numbers. So in this case, we are creating a variable called as n1. And the way we'll do that, maybe one thing I can note before even starting NumPy is we can use NumPy in our package by writing the command import NumPy. And when we do that, we can take the ideas of NumPy. So in last class, we looked at different modules. So NumPy modules and packages. So NumPy is a package that we can call into our notebook by calling the instruction import NumPy. Generally, what we do is, along with calling NumPy, we also uh, call it as an alias. Okay, so instead of using everywhere numpy.array, numpy.something, we use the short form import numpy as np. Okay. And here, as np is the alias for numpy, that is, instead of writing numpy, we can write np dot something, and that would allow us to use the functions or the variables that are defined within numpy. So this would be something in the beginning of the code that we'll write. Uh, yeah, and if maybe maybe by the end of the class, I can also run the code in one of your systems. And if NumPy is not installed, I can tell you the procedure of how can we install NumPy within our uh, uh, Python installation, so that this instruction can work out. So once we have loaded into our notebook, or we have added or imported NumPy as NP, then we can call a function called as dot array. Okay? So np.array is the function that we use to create arrays within NumPy. Okay? So here what I do is I say np.array, and as input to this function, I pass a list. Okay? And this list goes from 1 to 6, and they're just separated by commas. So in this way, what I'm doing is I'm creating a one-dimensional array using NumPy. I'm storing that one-dimensional array in N1. And if I try to visualize what this data would look like, is it would just look like uh, a series of numbers, 1, 2, 3, 4, 5. If I look at its shape, so its shape is basically that tells me what is the dimensions of this array. Then I can see that N1 has the shape of this. So there is just one number that defines that shape, 6. Now this 6 can be represented as maybe in a row, or it can be represented as 1, 2, 3, 4, 5, and 3, 4, 5, 6, and this would not make any difference because it's one dimensional. When you talk about one dimension, you don't generally talk about how many rows or how many columns it has, or at least in terms of NumPy, we would just say that it's a one-dimensional array. It can be represented by one number. In contrast to that, we can have a two-dimensional array, and the way we would write a two-dimensional array in NumPy would be something like this. We'll still call the same function np.array, and as input we'll pass a multi-dimensional list. Okay, so this list is what we'll pass. This list has two elements. The first element is a list that goes from which has a smaller subset of 1, 2, 3. The second element is also a list with a subset with values of 4, 5, and 6. And what NumPy array, what this ND array would interpret is, it will interpret the first element as the first row here. So 1, 2, 3 would be interpreted as the elements of the first row. The next 4, 5, and 6 would be interpreted as the elements of the second row. Okay. And what we would have now is we would have two rows. Let me call them R1, R2, and we would have three columns, C1, C2, C3. And this is how we generally would represent a matrix. And what NumPy has done is it has taken this multi-dimensional list and it has interpreted that as a rank 2 array with different number of rows and different number of columns. So here I have done a mistake. So when I look at its shape, then it should tell me that there are two rows and there are three columns. So this is a mistake. It is not 3, 3. It is 2, 3. Okay. So we see that while representing this shape, now it requires two elements to define it. The first element tells us the number of rows it has. The second element tells us the number of columns it has. Okay. So maybe at this point I can shift to my laptop to show some examples of how this will look. Let me look at the possibility of presenting both devices. Okay, this way. Stop. Okay. Okay. Are you able to see my screen? Okay. Great. So I have shifted to the NumPy notebook, and for this class we'll be shifting between the two sets and seeing how things are. So here we start by importing NumPy. So I'm just writing the code import NumPy as NP, and we are creating first one-dimensional or rank 1 array. The way to do that is writing np.array, and we are passing a list of numbers. So in this case, we are passing 333 and 333 as the list of numbers that will be converted into a NumPy ND array, n-dimensional array. Okay. So we get that value into an array. If I execute this, maybe I can restart my kernel and then start from scratch. Okay, so this is the first statement that we're executing. If I print the type of this variable, we can see that the type of this variable is from class numpy.ndarray. So we are sure that this is an n-dimensional array. We're going ahead. If I want to see what its shape is, so I do an array.shape, and that tells me how many rows or how many columns are there. So in this case, since we're talking about rank 1, there's only one number that represents this array. So here it says that this is having a size of 3. Let me maybe add some more examples here. Let's say if I add 45 here. execute this one, and then execute this one. It tells me that there are 4 elements now. Okay. So now, because this is a rank 1 array, we only need one index to access the elements. So let's say we want to access what are the different elements inside. Okay. So if I want to access the first element, I can write an array 0, and I'll be able to access the first element. Okay. So within square braces, I have to give the index that I want to access. So 0 would give me this, 1 would give me the second element, which is here 43. Again, this is 0 index. So to get the first index, to get the first number, I have to ask NumPy to return the 0th element. The first element would be 43. Then we can go to 2, which is 333, 3, which is 45. And if I go to 4, it should push me an error saying that index 4 is out of bounds for access 0 with size 4, because we don't have the fifth element here. I can write this in one line and I can print its number, so it will be able to access multiple at a time. You can also write. Okay. Now, if we want to, so this is one way of accessing the elements, but I can also update the elements using the same command. So if I want to update, let's say the 0th element with the value 888, I can say an array of 0 with 888. And when I execute this and I print an array, we can see that the first element, which was 3, has now been changed to 888. So that would be the way of creating a one-dimensional array. If we go ahead, we also have an example of how to create a rank 2 array. A rank 2 is basically a two-dimensional array, and we have to write this into this format. So here we'll see two examples. One is we'll create a list. So it's called I'm calling it a variable under list, and within that, if I provide this multi-dimensional list, that is the outer list contains 2 elements. The first element is a list of 11, 12, 13. The second element is also a list of 21, 22, 23. If I execute this part, and let's say if I want to see what is the type of another list, then it tells me that the type of another list is list. Okay, so this is just your basic Python list. To access elements inside the Python list, I have to write it this way. So under list 0, 0 would go to the element 11. It will say, okay, in my outer list, go to element 0, which is this list. And within this list, go to element 0, which is 0. So let's say access this 22, I'll have to go to 1, okay, 1 and 1. So 1 would be the second element of the outer list, and then the one here would be the second element of the list inside. So 1 would give me 22. Okay. Now similarly, in contrast to that, when I do that, when I access the same using NumPy, what I'm creating is I'm creating another variable, and I'm calling the np.array function. And to this function, we are passing this multi-dimensional list. And if I execute this, I can see when I print another, I get this neat format. Okay, so Python or NumPy automatically interprets this two elements as row 1 and row 2. Okay, so we have row 1 with 11, 12, 13, and we have row 2 with 21, 22, 23. If I look at its shape, that is, if I print this shape, I can see that I have, it prints this value, which is again representing 2 values, rows and columns. There's 2 rows and 3 columns, which is good. And I can access individual elements in this fashion. Okay, I can write another, so I don't have to write it in this format. That is 2 different square boxes, but I have to write it in this format. In one square box, I have to tell which row I want, which column I want. Maybe we can play a little bit with this one. Let's say if I write another, and I go for 0, 0, and I execute this, 0, 0 gives me access to 0th row, 0th column, which is 11. If I want to access 23, I have to go to row 1 and element 2, because this will be row 0, row 1, and this would be column 0, column 1, column 2. That is 1, comma 2. Okay, so when I access this, I can see I get 23. I hope this is clear so far, right? Okay, great. So let me shift back to okay. Just give me a second. Are you able to see my screen? No, right? I have to. Okay. So, uh, that was the first part. Let's move ahead. In this case, now let us explore at some functions that will help us to create NumPy arrays. Okay. So some of the functions that will help us to create NumPy arrays are like this. So maybe the first one to explore is zeros. So to these zeros function, we can know it's a function because it starts and ends with parentheses. We are passing a type here. Okay. Can you tell me the type of the variable that you're passing here? What is the type of this input?
It's a tuple.
Excellent. So it's a tuple, and it's a tuple with two elements. We are giving 2, comma 2. So this tuple gets interpreted as this. The first element is the number of rows that we want. The second element is the number of columns that we want. Tuple is a good way of putting this information. Tuples are immutable data types, and we are passing this as an argument inside to the zeros function. So in this case, I have already shown what the answer is. But you know, even if you had not seen the answer, it would have been easy to guess what it would do, is because of the name of the function. Okay, so the name of the function is zeros, and what it does, it creates matrices with all values as zeros. Okay, create matrices with all values as zeros. In this case, since we are putting 2 rows and 2 columns, it creates 2 rows and 2 columns with all values as zeros. Okay. Similarly, so this is a very simple function to understand. Let's go ahead. If I want to create the second type, which is I'm taking another function called as full, and to this full we are passing 2 arguments. Okay. The first argument is a tuple, again which represents size. The first element of this says number of rows. The second element says number of columns. The second argument to this function tells us what value do we want. We are creating a matrix which needs to be full. What value should it be full with? Okay. So here is the second argument. In this case, I'm telling let the value that is to be full be 9. Okay. So we come back here and it creates 2 rows and 2 columns, and all of those values are 9. Okay. Then we go ahead and we write our third function is the I function. And I function is a funny way of saying that we want to create an identity matrix. You know what an identity matrix is? Okay, great. Anand knows. Which knows. Okay. So an identity matrix is basically a matrix. It's a square matrix. For generally, it's a square matrix, and the principal diagonal of that matrix is 1. So maybe an examples make clear. So here we are creating an identity matrix. Instead of writing identity, we are calling it EYE. This is also for information. We have zeros and I function also available with MATLAB. So here in the I function, we are again passing a tuple with 2 rows and 2 columns. The first row is this, first row, second row, and then the first column, second column. Principal diagonal is all the diagonal elements going from your top left to your bottom right. Okay, all these diagonal elements will be 1, and everything else will be 0. So in this case, had we asked for creating 3 comma 3, our matrix would look something like this. We'll have 1, 1, 1, and then all other elements would be 0. Okay? So that is how our identity matrix would look like. Then we have the ones function, and just like the zeros function, the ones function is something that will create a matrix with all elements as well. Interestingly, then we have another function called as random, and if you look at this type, you would notice that all of the others just have np dot ones, whereas random here has np dot random dot random. Okay, so the way we'd say that numpy is the package, random is a module within this package, and then this random is a function within this random module. Okay, so we are calling the random function from the random module in the NumPy package. Okay, and here it takes two inputs again, representing rows and columns. And what it does is it creates us random numbers in 2 rows and 2 columns. So we get random numbers here. So these random numbers, they range between 0 to 1. Okay. So if you ever want to create random numbers between 0 to 1, we can call the random function from the random module. Okay. Let us shift back to NumPy and see how this looks like. Okay. So we will again. Okay, so in this case, if you observe here, it seems that I have imported NumPy again. But once NumPy is there within your module, this function, this line does not re-import it. It is already present in the module. It is already present in the notebook, and this need not be re-imported. So I probably just kept it as a case of if I was just running the program from here, I could still run without running the earlier commands. Okay? So I'm importing NumPy and creating a variable example1 and calling it with np.zeros 2 comma 2, and then I get an element of all zeros. Now these functions are good, or they are interesting because many of our implementations of linear algebra would need these kind of inputs. Okay, so if I have to define this manually for 2 cross 2, it is possible. But let's say if I want to create an array of 20 cross 20, then doing it manually would be a laborious task. Whereas if I have a function, I can just put 20 rows and 20 columns of zeros, and I get a neat output right there and there. Okay. Let me shift back to 2 comma 2. Similarly, if I want to create a matrix of filled with some value, I call the np.full function. So here 2 comma 2 and with 9 gives me this. But let's say if I want something else, 11 and maybe 2 comma 5, and it can do that also. So we have 2 rows and 5 columns filled with the value 11. To get the identity matrix, I put np.I. I think this will, okay. So np.I, which takes 2 inputs here, the number of rows and the number of columns I want. Let me try one more thing. If I just pass tuple here, will this work out? Okay, so the function np.I does not take a tuple as input. Rather, it takes 2 inputs. The first input telling how many rows are required and how many columns are required. And that will be the size of the identity matrix it will create. Let me go for 5 plus 5. This 5 cross 5 creates a matrix of 5 rows and 5 columns with the principal diagonal as having all values as 1. Then we have the ones function. Number of rows and columns, it gives us that value. So let's say we want maybe 5 rows and 2 columns. That will be 5 rows and 2 columns of ones. Okay. So here is maybe an interesting note. Let's say here, if I just pass one element here, what it creates is it creates a one-dimensional array, or it creates a rank 1 array, and we can verify this here, let's say if I create 6 elements here and I execute this, it creates 6 elements, and this would be just 6 here. So even though this looks like one row and 6 columns, we should not call it that. We will just call it a rank 1 array of size 6, because this is how NumPy functions. If I want to do some operations between a rank 1 array, rank 2 array, many of the times they are not possible to do that unless we go for broadcasting. But when they're not possible to do that, then we'll have to uh, probably reshape this to make it 6 rows in one column. So just interestingly, look at this answer, and then let me create another example. Let me call it example 4C, and we will pass 6 rows and or 1 row and 6 columns, and let's compare what this would create. So okay, so it does not work out for once. Oh no, I'm printing out 4B. Let me print out 4C. Yes. So what we create is we get here, you see these 2 open brackets and 2 close brackets. This represents, this has 1 row and having 6 columns. Whereas here also it looks like we are having the same thing, but it's just with 1 bracket. That is, this is a rank 1 array, whereas comparing to this is a rank 2 ND array. Let us go ahead. So again, we can create random numbers using np.random.random. So this is 4 cross 2. That is 4 rows and 2 columns of random numbers. As many times as I execute this code, it will create random values. Okay. So let me show you a few examples of running this. And you can see that we are creating random arrays from anything from between 0 and 1. So all the different elements keep changing.
There's a small doubt.
Yes,
Why we are calling random.random inside NumPy already a package called random we are calling, right?
yes.
Why?
So the when you go for huge packages, uh, and huge packages have generally hundreds of functions within that. So the people who own these packages or make those packages may want to organize things much better. So in this case, actually in this case, we will see later on that within the random module, there are several different ways of creating random numbers. So random here creates random numbers between 0 and 1. Then we have a rand_n function, which will take from a normalized distribution. Then we have a uniform function that takes from a uniform distribution, and so on. So here basically NumPy is a package. Random is a module within this package, and this module also has multiple functions. Okay,
Okay.
and because of that, we call it this way. I think if we do,
One more small doubt.
what are you saying?
One more small doubt.
Yes.
When we creating zero matrix, after each terms, there why it is a dot coming?
This dot here.
Yes.
So
It's a
we,
scalar vector something? No.
yes, the dot here or not depends, shows its data type. Okay, so what we can do is we can check its data type. So let's say we have created example 4C. If I do 4C dot and I check its D type, which is data type, I can see that this is a float variable. And because it's a float variable, we have this dot here. But I can choose to write something like this. So if I write D type is equal to, I think np.int64 and execute this, you see that dot is gone. And if I
Okay.
look at its data type now, that is an integer variable. So by default, NumPy creates float variables instead of integer variables. And because of that, it just shows dot. Dot and then followed by no numbers means basically it's 0. So it's 1.0, 1.0 and so on.
Okay. Okay. Fine. Fine.
Okay. I was doing this, if I do dir np, then I can see that these are the different things available within the NumPy. And let me go to random. OPQR. Okay, so from here I cannot know if this is a function or not, but if I do np.random and then do dir, I can see that within random also I've got multiple stuff. Okay, and There are multiple stuff like I was telling. Rand n is get random numbers from a normal distribution. Rand int would be get random integers, and then there will be a function called as uniform that tells me get random numbers from a uniform distribution and so on. Okay. So generally, huge packages they will have instead of just having everything into just NP, they would choose to define things in a more organized fashion. Now, once we create this example, we can choose to update some elements. So in this case, we are updating one row, first row and first column. So in this, the first row and first column is this element 5. If I execute this, we can see that here, this element gets replaced by this element. So I'm just showing some examples of how to use functions. Okay. Do you have any questions in these functions that we have seen so far? Okay. Okay. So these are commonly used functions. Of course, NumPy is a huge package, okay, and there are hundreds of functions inside. We'll not go through everything. We'll just go through the most commonly used functions that will make our feet wet, so that we can, do stuff within NumPy. Let me go shift back to the slides. Okay. I hope you're able to. Okay, I have to stop sharing here first. Okay. So we're back to our slides, and we look at different ways of indexing. And within NumPy, we can index using integers, we can index using slices, and we can index using Boolean numbers. Okay. So integer indexing is something that we already saw. Let's say I have a variable n1. I can access it by passing elements here. So within the square box, I can define which row, which column I want. If it is a rank 1 array, I can just pass the number here. So this is all 0 indexed. So I can pass one integer inside that will be able to access the different elements. So let's say n1 looks something like this. Then writing 0 would help me access this element. If I want to access this element, I have to write here 0, 1, 2. Had n1 been something like this, if this was maybe 2 rows and 2 columns, 2 rows and 4 columns, then I would have to put 2 numbers within this block. Okay? So in this case, let's say if I want to access this guy, then I would have to write row 1 and column 0, 1, 2. So writing 1, 2 would help me access this element. And this is an example of doing integer indexing. That is, we are writing integers to access the different elements. But sometimes we want to do more advanced stuff. That is, we want from this set, we want to access a bigger region, okay, or a bigger slice. So maybe I'll give you an example. Let's say we want to access this block here, okay. So I want the first 2 rows of n1 and I want the first 2 columns of n1, okay. So for doing something like this, I have to do something called as slice indexing. So here we would write something like this. We'll write n1. So again, within square box, I would have to define what are the rows I want, comma, what are the columns I want. So the rows I want are 0 to 1. So I could write something like this, colon 1. And the columns that I want is again 0 to 1. I can again write this, colon 1. Okay. So in Python, if you remember our class on lists and on data types, and we discussed about strings and lists, this is also a way that we will access different elements in the strings and list. So when I don't pass the first value, then it takes a default value of 0. Colon 1 would say go till this number. Okay. In fact, here colon 1 would not work out. I'll have to write colon 2. Okay. Probably I need to verify this. We will look into the example and see this. Okay. The colon here suggests that I'm not going for just one value, I'm going for multiple values. Okay. So whenever I create multiple values, it's called a slice within NumPy. So here colon 2, this would be translated as something like this. It would be translated as 0, comma 1. And this guy would be translated as 0, comma 1. So it starts with 0 and it goes to a value of 1 less than this number. Okay, so since this is 2, 1 less than this number is 1. So when I do this, or when I try to index this part, I'll be able to access the 0th row and 0th column, and the first row, 0th row and first row, and then 0th column and first column to get these numbers. Okay. Maybe let's look at a different example. And in this case, we want to extract something like this. Maybe I just want to extract 2 and 3 here. Okay. And to do that, the code I will write is, I just want 0th row, so I will write 0 here. And I want 2 columns, which is starting from 1 and going till 2. Okay, so I will write 1 colon 3. Why 1 colon 3? Because by writing 1 colon 3, I start with 1 and it goes till 2. It will go 1 less than this number. Had my box been something like this, so had our box been something like this, we'll have to write 1 colon 4. Okay. Why? Because then we'll write 1, 2, and 3. So this is the way that we will access slices within the array. We have seen integers, we have seen slices. The other way is called as Boolean indexing. And in Boolean indexing, what we do is we write out our selection in terms of Boolean values. So let's say I want to access these two elements. I will have to write something like this. I will have to write n1 and I will pass elements like this. I will write false, true, true, false, and this would be the first row. And the second row will again just be false of everything. Okay? And what this would do is it will return to us those values which has true. And everywhere it has false, it will simply ignore. So while doing Boolean indexing, we can do it this way, but this is not what we generally do. Boolean indexing is done to select a certain criteria. So in this case, my criteria would be, okay, maybe we'll shift to the notebook and see what this looks like. We'll go back here. Okay. So in this case, we are taking an example of an array with 3 rows and 4 columns, 11, 12, 13, 14, 21 to 24, and 31 to 34. So arrays, integer indexing we've already seen. Let's look at slice indexing. In this case, we want a slice here. Okay, so we are going for which rows? We are going for row 0 and row 1. So this is row 0, row 1. Which columns? We are going for columns 1 and 2. So this is column 0, column 1, and column 2. So now we are trying to access this block here, 12, 13, 22, 23. And when I execute this and this, I can see I'm able to extract this part 12, 13, 22, 23. Okay. So maybe can you tell me if I have to extract this 22, 23, 24 and 32, 33, 34, what command should I write down here? Is it saying something? Okay. If I have to access this and this, what should we write down here?
One more extra comma will come after that.
I'll remove this. You tell me what this would be.
Comma 1 to 4, comma 1 to 4. Maybe it will work.
No. So in this case, so we just passing an array will take number of rows and columns. So this initial comma is not required. And here, since I want these values. So how many rows are there? There are 3 rows here.
3 rows.
Row 0, row 1, row 2. So here I want to go from row 1 to row 2. So it will be 1, comma 1 to 3. Right? 3 means 1 less, it will go till 2. 1 to 2. And here we want 1, 2, and 3. So this is columns is fine. So when we execute this, we get 22 to 24 and 32 to 34. I hope this is clear to everyone. Okay. So this is how we would get slices. An interesting thing to see here is what we have done is from our bigger array and array, we have created a smaller value called as a slice. Okay. And if you modify the slice, so I'm just printing the slice here. If I modify the slice, the original array will also get updated. Okay. So let me show you an example. So before, let's say we are looking at, let me try to update this value 33. Okay. To update this value 30 or to verify this value 33, let me print the whole thing. So before modifying, before we'll print an array, so this entire thing will get printed. We'll modify this value. So to modify this value in a slice, for a slice, this value 33 is row 1 and column 1. So I will say row 1 and column 1, update its value to 1000. Okay, and after that, print again an array. So when I execute this, so this is before we have updated, we have seen this is the value. And then after we have updated the slice, we can see that the original array also got updated. So within NumPy, updating a slice is basically a subset of the actual array. It is not creating a copy, but it is actually taking the same array and using or showing as a subset of that. We can do both integer and slice indexing. That is, one of them can be an integer, the other can be a slice, and that works out. So when I give a number like this, it says start from 0 and go till the end. Okay. So here in this an array, we have 3 rows and 4 columns. If I take an array, I go for which row? Index 1. So this is row 0, row 1. When I go to row 1 and I do a colon like this, a colon says take all the elements. Okay. So which gives me all the elements here, 21, 22, 23, 24. If we look at the shape, we can see that this is a unidimensional. This is one dimension array. Okay. Or it has created that into a rank 1 array. But instead, if I don't want this to be a rank 1, I wanted it to have the same dimensions as the one earlier, then I would do something like this. I will say access 1 to 2, which basically translates to 1 only, and then all columns. And when I extract it this way, the same result, we get the same result as earlier. But now if you look, there are 2 square brackets here and 2 square brackets closing, which suggests that this is a rank 2 array, rank 2 ND array. And when this is confirmed by when we look at its shape, we can see this is 1 row and 4 columns. Yeah, so let's look at Boolean indexing. So we are taking another example here with 3 rows and 2 columns. If we create a condition like this, so we are saying create a filter where we have an array greater than 15. So what it would do is it would create a Boolean index for this array. I'm just storing that index into a variable filter, and I'm printing what filter would look like. In this case, we can see that wherever this criteria is met, that is wherever this number is greater than 15, which is these bottom 4 values, we get a true there, a Boolean index of true, and in the first case we get a Boolean index of false. Okay, so we have a list of true and false that represent this Boolean idea. Go ahead. Now with this Boolean indexing, I can filter out or I can extract elements from the original array. Okay. So when I do something like this, from an array, choose filter, wherever we had found true, those are the elements that it will return out. Okay. So it returns out 21, 22, 31, and 32. Wherever it was false, it does not return those values. So it can act as a filter, which can be a very neat trick. That is, let's say I have this array, I want to extract all the even numbers here. So I can simply put the condition that from an array, extract this Boolean condition. What is the condition? Wherever you take an array and modulo 2 is equal to 0. That is, whenever I divide each element of this array with 2, and if I get the remainder as 0, filter out those elements. So it filters out all the even values, that is 12, 22, and 32. And this is useful when you want to modify certain values with some criteria. In this case, I'm just showing an example where I have to write a code where I want to add 100 to all the even numbers. We can simply filter out these values here, and we can do a plus equal to 100, which will say take the previous value and add 100 to each of those numbers that satisfy this criteria. When I execute this, I can see that 12, 22, and 32, we have added 100 here, so it becomes 112, 122, and 132. Let's look at arithmetic operators. So we'll shift back to the screen. Okay. So we have arithmetic array operators of addition, subtraction, multiplication, division, square root, exponential, and so on. So there are some basic operations that we can do with NumPy arrays. And if you remember when we were doing an addition operation on list, that is, if I have two lists having the values 1, 2 and having the values 3, 4, when I add these two, what Python by default would do is Python by default would create a bigger list with all these 4 elements. It will not do arithmetic addition. Okay? This is where NumPy comes into picture. And when we actually want to do arithmetic addition, NumPy will help us. It will say, okay, if I have, if I have two matrices, let me write this neatly. If I have two matrices, 1, 2, 3, and 4, and I add to another matrix, maybe 4, 5, 2, and 3. If I add these values up, it will do a true matrix addition. That is, each value here will get added here. So 1 and 4, they add up to give me 5. 2 and 5 give me 7. 3 and 2 give me 5. And 4 and 3 give me 7. So I get true matrix addition by by adding elements in NumPy. Similarly, if I can, instead of addition, if we had done subtraction, it would work out that way as well. When we do, so we can do addition, we can do subtraction, we can do multiplication. And what multiplication at this point will do is it will not do matrix multiplication, but it will do element-wise multiplication. That is, each element will be multiplied to its corresponding element in the second array. So 1 times 4 will give me 4, 2 times 5 will give me 10, 3 times 2 will be 6, and 4 times 3 would be 12. So I would get this as the answer, which would be taking each element and multiplying it with its corresponding term. And that is what matrix multiplication would do. So in terms of MATLAB, I would call this something called as element-wise multiplication. Okay. So, and I'll have to operate it using the dot asterisk operator. Whereas in Python, your basic multiplication gives me this answer. Similarly, division would mean that I write the divide function, divide operator, and this would divide each of the elements with each of the elements here. Okay. So I will not take the task of doing that because I'm sure I will end up with some fractional numbers and I'll make a mistake. But element-wise division would be taking each element and dividing correspondingly with each other. Okay. Square root and exponential are not operators that we can use in NumPy, but these are functions that we will have to use. So if we use something like np.sqrt, then I can do the arithmetic operation of square root, of taking the square root of each and every element and then whatever variable that we pass here. So let's say at this field n1, then each element of n1, we would be taking its root. Okay, we would take its square root. Similarly, instead of square root, if you want to take exponential, you will do something like exponential. If you want to take sine, you will take something like sine or cos or so on. And all the different numerical operators that we have, we could have taken those and applied it to the array or to the n-dimensional array within NumPy, and we would get those corresponding arithmetic operators. Shift to my screen. Okay. So here, let me also club data type. So we already saw data type, but maybe we can check it out here. So here I'm creating two different matrices. The first one is X. So this has 2 rows and 2 columns with these numbers, and its data type is integer. We can say np.int, and when I print X, we can see that we have got this X. Similarly, we are creating Y, which has these values, 211.1, 212.1, and so on. It is just float values shown by the data type here. Even if you don't write data type, it would automatically take it to the float value. But anyway, since we wanted to be more specific, we're defining this to be a float. When I print Y, I can see that I get this one. Now, when we do matrix addition, I can take X plus Y and I get this answer. We could also call the function np.add and pass it the two parameters X and Y, and it would result into adding these two numbers, adding two matrices. Similar to addition, we can do subtraction by minus, or we can do subtraction by np.subtract and passing the two arguments. We get subtraction. We can do multiplication by doing x asterisk y. That would take each element of x. So 111 multiplied by 211.1 gives us this number. So we can multiply that way, or we can do multiply by calling the multiply function and passing two elements. We can call divide, that will give us division. If you want to take square root, we'll call np.sqrt, and that will take square root of each of the elements of x. And np.exponential will take e raised to x for each of the cases. Okay. So probably I should ask you guys now. We have finished 1 hour. Do we continue? If we continue another half an hour, we can finish NumPy. Or if we, it's also okay if we do it in the next class. So what do you suggest, Srivas?
Actually, it's going to be too much, I guess. I think.
Sure. We can continue this in the next class then. Okay.
Yeah.
So let me just summarize what we have seen. So we have seen n-dimensional arrays. We have seen some functions to create arrays. We have seen how we can do indexing and arithmetic operators. Okay. So in next class, we'll look into some statistical methods and sorting and how we deal with sets within NumPy. We'll look at broadcasting and we look at some extra features. So so NumPy is a huge topic, okay? And what we are aiming for at this point, we are not going to master everything within NumPy. We're just getting to know the basic features that will help us to do our machine learning and data science tasks. Okay. So with these in mind, we are just looking at a small set of things. And with this set, the hope is this, that if at all we need something else in our data science journey, since we understand these basics, we can read the documentation for NumPy and get some other extras that we can that we'll be able to use for data science. Do you guys have any questions? Okay, great. So in that case, we will end this class. We'll continue. So you must have gotten your calendar request. So I have already scheduled on alternate. So maybe Monday, Wednesday, and Friday we can have classes in the morning, and yeah, I will update. So if some change happens, we will update that in the calendar. Otherwise, we'll continue with the schedule. And yeah, that's it from my side. Okay, then have a
Okay,
great day.
bye.
Yeah, have a great day. Bye bye.
Okay, bye.